Good morning, everybody, and esteemed panelists from America and Australia, and good afternoon. Sorry, good afternoon and good morning to the viewers and esteemed panelists and organizers in India. Myself, Amlan Jyoti Kaur, and I'll be speaking on the topic as I already told. So I'll be sharing my working experience being a professional, especially in groundwater. Also, I during my course of studies and in my service, I tried to also amalgamate the the other aspects of surface water, rainwater, all these things. And I'll be speaking on my experience, what actually it is being experienced in. Of course, I'll be restricting my lecture on West Bengal only, and it is also the theme is that Bengal Basin is one of the that group's theme. So I will restrict it to West Bengal, but since geology and geographically also it is contiguous to Bangladesh, it will be covering almost everything of Bangladesh except the northern part of Bangladesh, which falls in that Kumilla and Chittagong districts. Sometime back, one of my friends in World Bank, actually, he was preparing from he was from England. He was preparing some note on Bangladesh, but he was not getting it. So he requested me that you worked many parts of India, so can you help me? So I also helped in this way. So I hope that when Hydrogrameen projects, if it is endeavored in Bangladesh also, we'll be able to give our expertise from India in association with our friends and counterparts in Bangladesh. So I am entering into my lecture. Well, my topic is quantitative and qualitative issues of groundwater river basins in West Bengal with reference to deltaic islands of Sundarban. So as Professor Biswas was telling, basically whatever the surface water and groundwater, whatever it is happening, it's recharge, discharge, whatever it is generally described, it is assessed in terms of water basins, that is river basins. So in Bengal, actually three major basins are there, but these are actually Brahmaputra basins. If you look at this is the Brahmaputra basins covering three districts of West Bengal, that is Jalpaiguri, Coach Bihar, and Darjeeling. Whereas the rest part, major parts of West Bengal, it is covered by Ganga basins. From here you can see even in this part the river Mahananda is there, but it is debouching into the river Ganga. Actually, ultimately,
sorry to interrupt, your PowerPoint is not visible, sir.
How? You cannot see it.
But we are seeing clearly.
I can't see Dr. Kaur as well. Can you reshare again?
But it is visible to us. How it is possible?
Okay, reshare.
Okay.
Yeah, it's good, Dr. Kaur.
It's visible now?
Yeah, it's good. It's good. Go on.
So as I was telling you, three basins are there in West Bengal. One is Brahmaputra basin. Ultimately, it is going towards south east direction, and ultimately it goes into Bangladesh. This is the Brahmaputra basin. It is incorporated in three districts of West Bengal. That is Darjeeling, Jalpaiguri, and Coach Bihar. Major part of West Bengal, it is covered by Bengal basin. Right from here, you can see even in parts of Darjeeling, it is there that the river Mahananda it is ultimately flowing southward, and ultimately it is debouched here to the river Padma. And this entire basin up to this limit, it is covered by the Bengal basin, that is Ganga basin, and which is actually shared with Bangladesh. And only a small part of West Bengal it is covered by Subarnarekha. Particularly, it is coming from nearby Tatanagar, and it is ultimately passing through the Jharkhand, then parts of Odisha and West Bengal. It is falling here. So the major basin that is actually covered in the state of West Bengal, that is Ganga basin. So this is all about. And if we look into, since rainfall is a very big issue, because it is as Professor Biswas was also telling, that rainfall in their country it is less in comparison to others. So actually it is actually basically it is forming the major part of water resources, the surface water, then also it replenishes groundwater. So here again in the northern part it is very high. It is to the tune of 3000 millimeter or more. But if we move towards south, so here in the range is around 1500, whereas in the Gangetic part, in the coastal districts, the rainfall is to the tune of 1600 to 1900 millimeter. So whatever it is in comparison to other parts of India, the rainfall what is received in the state of West Bengal, it is quite appreciable. So in terms of, because of it is getting lot of water, sometimes in spate, rivers are in spate, especially in the rainy season. We also get flood hazards, and we are having number of majority of the many parts of West Bengal where flood is a problem. Here we can see the areas both in North Bengal as also in the southern Bengal. There are several districts which often it suffers from flood hazard. And especially since it is in the end part of the riverine system, except the Brahmaputra river, the Ganga, in the Ganga basin, it is in the end part of the basin. So here the slope is very less. So you can well imagine. Here the slope is very less. So it is also difficult to get the water. Restricted on the way through dams, etc. And only in the western part of West Bengal, there are some problems, some water scarcity problems are there. So we find also drought. These are the drought prone areas. You can see this yellow part. These are the areas. Basically, it is covered by the districts of Bardhaman, western part of Bardhaman, then Purulia, Bankura, and West Midnapur districts. Now I'm coming into the basic thing, that is geomorphology. You know, geomorphology, as Professor Biswas also was telling, geomorphology it is a big factor which governs the surface flow as also groundwater flow and groundwater recharge as also its discharge. So this is in this part actually it is high hills, that is Himalayas. Also in the western part it is a plateau area, that relief also is quite high, but in the other part it is quite less. Maximum in some places here in these areas it is 20 to 30 meters. But if we come to the coastal part or in the southern, the extreme southern part, southeastern part of West Bengal, close to the Bay of Bengal, the relief is within 8 to 9 meters to mean sea level, up to that. That is the range. And if we look into the geology and hydrogeology of this Bengal state, we can see another. This is extra peninsular area, that is Himalayas. It is covered by hard rocks, and also in the western part, in this part, which is basically the drought prone areas, it is covered by hard rocks. But rest part, entire you can see the entire part that is falling in parts of Brahmaputra and also in Ganga basin, as also in small part of here in Subarnarekha basin. These are covered by alluvium, which forms prolific aquifer. So now I am coming into the crux, into the problem what government of India, government of West Bengal, and here people are facing. In India, actually, the water availability scenario, rainfall availability, as also the geology is also quite varied. Because of this, I am not entering anything into India, but still I want to give you some glimpse In India, major part of India, it is almost now, it is so water stressed. One of our co-speaker, she was telling about that was the water stress was maximum that was shown in India. It is that part. It is that part. It is totally water depleted now. Now groundwater extraction is totally almost it is not possible. Also in South India in major parts, but whereas in this part it is still groundwater is there. So in matter of food security, Government of India has planned. Actually, I was also there in the headquarters of my former department where I was working, Central Groundwater Board. So I had a chance to work in the entire country. So I know about the situation also in many parts of the country. So here you can see in this blue part, these are the areas where the focus is changed. Government of India is now telling that at least if there is some agricultural productivity, we have to, for the food security of our country, that should be in this part of the country. So in the eastern part or northeastern part of India, the focus is changed that there should be some boom, there should be some increase in agricultural productivity. So because of this, lot of problem has been cropped up, and accordingly, the water table has been started depleting in the state of West Bengal for the last say since 80s and onwards. There has been huge, withdrawal of groundwater, which has caused quick depletion of water table. As also it has been noticed in some urbanized area like Kolkata Municipal Corporation area, as also in some industrialized pockets like Holdia Industrial Complex. In these parts, lot of groundwater declined because of usage of want to give room for agricultural productivity, that is irrigation, as also for urbanization, as also for industrial development. There has been huge extraction of groundwater. So while India is the highest extractor of groundwater in the world scenario, in West Bengal also, although it is having prolific aquifers, it is having huge potential of groundwater. Still, here also groundwater has started facing some stress. So this is an account of because of that agricultural productivity, lot of shallow tubes came in, and so because of this, the water depletion is there. So here is some statistics that the increase of that shallow tubewell, and it is because of one summer paddy. It is entirely depending upon groundwater. It is because of that extraction that water depletion has been caused heavily. So this is that productivity of that summer rise, this area, and also the rise in shallow tubewell. One statistics it is showing. And also, if we look closely into the status of that extraction, in some parts of West Bengal, it is in the acme. It has been for the last 20 years. It is a huge quantity of groundwater. You can see, if you look at this part, you can see the number of shallow tubewells. It is in the central, we can term it as a central alluvial tract of West Bengal, where the agricultural productivity and also extraction of groundwater has been highly accentuated. So if we look into, because from Central Groundwater Board as also Government of West Bengal, we assess the groundwater resources in regular interval. So here it is one statistics. It is showing that 2004 onwards till the latest census of 2017, we can see the category of the administrative blocks. Actually, we give it in terms of safe category blocks, semi-critical category blocks, critical category blocks, and overexploited. Till now, it has not reached overexploited, as we are having huge number of overexploited blocks, as I was showing in elsewhere in the India. But here already that critical blocks has been increasing. In the latest census, we have found from 1, it has jumped into 30. So it is clearly indicating that how it is actually going ahead. So in West Bengal also, we are getting stress of stressing groundwater system. And this is that area I was telling you, that central alluvial tract. Here actually that huge extraction is going on, and also it is now being observed in the entire state. You can see it is a long-term trend of groundwater level. So here also we can find that it is depleting. So mostly in the rural areas, because of that agricultural productivity is there, and so I have given a few select hydrographs from the wells in various parts of West Bengal. These are showing that all are showing some depletion trend and a depleting trend. Majority of the wells in many places it is showing more than 0.5 meter to 1 meter per year. It is going down. It is depleting. So same feature we can see in Calcutta Corporation area as also in Haldia complex. So Haldia industrial complex. So this is the entire state. This is the area where water depletion has taken place. So these have caused huge, high incidence of that quality deterioration in our state in groundwater. This right one, you can see these are the areas where actually high arsenic pollution was found, but here the limit is 0.05. It was a formal limit, but in 2012 there is that Bureau of Indian Standard, and with the advocation of Government of India, in 2014 ultimately it is enacted. The limit has been changed to 0.01, just like WHO standard. I am just coming into that how it is looking, but it is in the left side. I can show you the other pollution pollutants what actually are ailing the groundwater in the state of West Bengal. This is this area. This is arsenic infestation. Then these are the fluoride affected areas in groundwater. These are the blue one is fluoride affected areas. And also we are having another major challenge, that is in the coastal area, we are having salinity. And here in few blocks, we are getting some different types of some combined type of pollution. Here we are getting in the coastal areas, we are getting arsenic as also fluoride. These are Baruipur and Sonarpur area where we are getting both arsenic and fluoride as also salinity problems. So these are the problems. And as I was telling you, while that arsenic permissibility limit was made as per with the WHO standard, now we have found that formerly it was 83 blocks in West Bengal. Now we are getting 104 number of blocks. Even we are started getting arsenic in parts of it is Coach Bihar, as also it is Gwalpokhar, as also in it is in Balurghat. It is a statistics or data from Government of West Bengal PhD. So so it is there. So in other areas also that arsenic has been started. We are detecting arsenic in groundwater. So these are indicating that these are directly because of huge extraction of groundwater it is happening. This is one of the model diagram through which from groundwater it has also been observed. Everybody knows now, it is proved both in India and Bangladesh that the shallow aquifers, those are actually ailed with arsenic. Those are having the problem of prevalence of arsenic in high incidence or below above permissible limit, whereas the lower aquifers those are free. So we are through cement sealing technique in central groundwater board, we have developed it in 90s. So we are extracting the aquifer from the water from the safe aquifer. This is one of the techniques. And in West Bengal, the Department of PhD has done a lot of good works and in arsenic-free water supply, both from surface water as also from. They have also taken some pond water projects after filtration, then dug well projects, etc. But basically, they are actually trying to give people safe drinking water from the rivers. So and in urban areas also in Calcutta, as I was telling you, Calcutta in the last 60 years, we have seen a lot of decline in groundwater. In the latest part also, it is going on. In some parts, there were some change after the legislation. I will tell just in few words about legislation in India as also in West Bengal. Although there is some legislation, still mining is still going on, and it is sterilizing the city of Calcutta. So it requires some interventions. So this is the part. This is a core part of the area where there has been huge depletion of groundwater, which requires immediate recharge and other practices to be taken up. And also in many blocks, several blocks in wards, that is municipal wards in Calcutta Corporation, the arsenic has been detected. So and this is also another conjectural picture. Many people who works on that climatic change and global warming, it is there because through sea level rise, this is here it will be Calcutta. Calcutta will be here. So in Calcutta and major parts of Bangladesh, those can be inundated with that ensuing sea level rise, which is actually basically going on. So this is the part, and another thing what may endanger the Calcutta Corporation area, that is with huge extraction, it may cause subsidence as it happened elsewhere in the world. So with this subsidence, this will also facilitate the inundation, especially during the high tide time. Water may engulf into the city. So these are the problems. So now I'm coming very brief about the law as it happened elsewhere in the country in 1997 with the verdict of Supreme Court of India, Honorable Supreme Court of India. Central Groundwater Board, my former department, had got the authoritative action as a central ground. It emerged as a central groundwater authority as well. So groundwater legislation started in the entire country, and in West Bengal government, we have handed over it to West Bengal government in 2005. So I have started created state groundwater authority, as also in corporation, Calcutta Corporation, the corporation level authority is also there. So they have restricted new construction of oil, but still in the fringe area it is going on, and over extraction, that is the problem. It is happening in Sundarban area. Main problem is that in Sundarban aquifers are not at all prolific. In West Bengal we are getting huge thick aquifers in West Bengal. In other parts of delta, I mean that alluvial West Bengal, alluvial tracts of West Bengal, where we get huge, we can get huge quantity of water, and having those are having huge thickness, maybe 15 meter, 20 meter, 30 meter, even 30 meter thick aquifers are there. But if we go to Sundarban areas, those are actually ultimately it is the groundwater at depth of 200 meters and below. Those are being divulged into the submarine discharge into the into Bay of Bengal, and those small aquifers, patchy aquifers, are getting little water, which is only thrivable for the people for their drinking water. But the people are venturing for irrigation tubewell. In the last few years, this dangerous trend has been found, and in 2011 to 16, it is a block figure. It is collected from one NGO working there, Prasadi. So we are the 175 number of wells in constructed, which is a very dangerous trend. If it is happening in each and every island, in no time there will be salinity increase. This is the problem. The Sundarban people, many of the islands in Sundarban, good potable water is not available. So few of the interventions what may be undertaken here, that is artificial rain recharge, as also rainwater harvesting. But and a few of the pilot projects are already we have taken up in the city of Calcutta, and Kolkata Corporation has given me the task to prepare a report on that, and I am preparing it, and I will submit it very shortly, and so that it is mandatorily it is done in each and every municipal ward. And few of the interventions of government of West Bengal through that Mahatma Gandhi employment generation scheme, as also from World Bank aided scheme. These are the pictures from World Bank aided scheme. These are in water scarce areas of Iibhb and Purulia, and you can see in the water scarce that is water scarcity is still there, because there is no shallow aquifer in Sundarban and other areas. So here the silted rivers are actually turned into big pockets of through desiltation, big pockets of that rainwater harvesting. So these are actually creating huge irrigation potential in these areas. These are few of the interventions through of rainwater harvesting, as also recharging the shallow aquifers through construction of ponds and water bodies. So these are under Mahatma Gandhi employment schemes, generation schemes, and these are through people's participation, and also they are getting some that wages from that. So this is the way. This is some picture about the actually one of my co-speakers, she was telling about the climatic change. I also have been working on climatic change in the Himalayas for last several years. So this is also in Himalayas also West Bengal government has started some work. Actually the springs, which is the lifeline in the hilly districts of West Bengal, they are it has been highly lowered, and recently that government that World Bank aided project, as also that rural development through the interventions of few NGOs like Aquadem of Pune, as also Prasari in West Bengal, they are also doing some good work, and they are making some good efforts in recharging the slopy aquifers, that is slanting aquifers on the hill slope, so that the springs are rejuvenated. So these are few of the few of other pictures. So this is all about my thing what I wanted to put forward. Thank you very much. And this is my email. You can contact me for any further queries. Thank you very much.
Thank you, Dr. Kaur. Thank you. Thank you very much. You have indeed given us a preview of the qualitative and quantitative depletion of groundwater in West Bengal. And you have also spoken that there are few solutions which are already on work, but we need to find out more cost-effective solutions in that regard. Thank you very much. Now, let me welcome Dr. Aftabuz Zaman, who is internationally renowned scientist, specialization with agriculture. Yes?
Dr. Carr, can you stop sharing your screen?
Okay.
Please.
Hello, good. Hello.
Dr. Kaur, can you go up on your
Hello.
windscreen and
Hello.
stop sharing?
No, it is not from my screen. It was from there. The organizer host disabled it. It is not from my skin.
No, Dr. Zaman, it's okay.
Yeah.
Yeah.
Okay, no problem, no problem. It is. Are you hearing? That's the main issue.
No, it's all.
Then
it's
we
okay,
can
it's
start.
okay. Sir, your
Video is not.
Your video is not on.
No, I did it. It is there telling.
Okay.
It is on now. It is on now.
Okay. Fine.
It is on now.
Okay.
It was disabled from your corner.
Okay.
Okay. Let me start. Okay. Good afternoon and good morning to all, because from India it is good morning, and from other state maybe good evening or good afternoon. Okay, let us start. Actually, my topics, but today's topics of discussion is what next in global water crisis. I have no slide. I shall not make any presentation. Just I shall give some brief or salient point on which I am thinking hydrogrameen, and what is the situation now prevailing on due to COVID-19, and what's agriculture affected, and how we can remedial measures, how we can take from this. This is my topics in brief. So our topics is what next in the global water crisis, issues, solution, and hydrogrameen. But my topics is hydrogrameen technology in construction of Indian economy in context of novel coronavirus, COVID-19 pandemic. This is my topics. So naturally, I am a man of water management in agriculture, and I have some experience on that in my country, in India and in West Bengal. So I shall first tell something about the water management in agriculture. What do we think like that? Then I shall correlate it with the COVID-19 and hydrogrameen technology. Then it is 5 minutes, 15 minutes. I think I have some other program also. Okay, actually water management is subject which we thought previously. Dr. Kaur told the groundwater management and all the things, groundwater recharge, groundwater reservoir. So it is also part of it. You know, primary source of water is rainfall. Rainfall is coming on the earth and it is being penetrated to underground, and it makes groundwater and surface water, and which is flowing in the surface. But if the rainfall is main source, primary source, then how much rainfall we can use? Only about 15% of the precipitation or rainfall we are being to use. Otherwise everything unused, flow, and going to almost wastage. So part of it is precipitation, part of it is I say evaporation, and part of it is recycling. So only 15% is usable rainfall we are using in the agriculture scenario. But whatever agricultural background is that, when we are thinking for water management, why you are thinking for water management? We are thinking for water management because due to introduction of fertilizer and irrigation responsive high yielding varieties of crop, different crops, cereal crops, and the other crops also, not hybrid variety, but even some hybrid, even some improved varieties, they consume more water and more fertilizer. Remaining the fertilizer you keep it aside, but I am telling more water they need. But particularly in the rainless period, that is winter, or you call say summer or autumn season, that is after rain season ceases, then there is no much source of water. But we have developed so many crop and crop production technology and so many crops that can be grown in Rabi season, that is in summer season or winter season. So many crop we are growing now. Previously it was only one single crop in rainy season. So it was not matter that underground water is depleting or we are finishing these resources. But nowadays, as because the agriculture has been changed, intensive cropping system and all the agricultural technology with all available inputs, we can have changed our agricultural production, and it was our of the need to give food, more food production for the population, ever increasing population of our country. That's why we think of that how to use underground water of underground sources, groundwater level, groundwater resource. But we are not recharge of groundwater has got some limit, because excess rainwater is being recharged, a portion of it is being recharged as groundwater, but it has got some limit. So it is not much we can recharge it. So we are thinking for artificial recharge of groundwater, so that groundwater cannot be finished, or some health related problem like arsenic, fluoride, because if the groundwater is being extensively used, not only the problem of water availability, but so many heavy metal concentration in the underground sources is being more and more. And we are getting so many problems like health hazards and other problems we are getting. Not only the disease and other thing, so many things are happening due to the groundwater resources is being finished. So we have to recharge it as much as possible. Because if we think that in India, several parts of India, still now, we are getting good amount of rainfall. But this is not, it is uneven and not equidistributed throughout the year. In a short period, we are getting more rainfall in a manner that we cannot restore it, we cannot reserve it, we cannot take it account that it can be reused later on. So it is causing flood, and flood is also cause of distress of the people. Heavy amount of water, excess rainwater with short span of time will cause flood. Even the rainless period, we are getting so many rainless periods that is causing drought. So that is also another natural phenomena that we are causing from it. So due to uneven and unequal distribution of rainfall throughout the year, we are getting such problems. Still now, India has got several types of rainfall, annual rainfall per year. In Cherrapunji, we are getting more than 10,000 or 17,000 millimeter of water, annual rainfall. Whereas in Rajasthan, we are getting 600 millimeter of water, annual water. We are getting annual rainfall, or we are getting less than 600 millimeter. So most of the period are keeping us water balance negative. But we have to develop our agriculture. So we have to think of how to effective water use and how to recharge more and more underground water. So when previously we are thinking for water management, we are plainly thinking for irrigated agriculture, because irrigated agriculture has brought the change in agricultural production scenario in India. But nowadays, so many work has been done under the irrigated agriculture, how the water should be managed. Dr. Kaur told something. So I am telling in agricultural perspective, but I am telling still now, we are not in position to use judicious application of water in crop. And water management, to make it success, I think some new concept I am telling some relatively new concept, that is rain-fed agriculture also giving much contribution to agriculture. But rain-fed agriculture, there is no provision of irrigation, but water management is there. So we have to take account of rain-fed agriculture, like wasteland. Thanks to John Bravo, she told nicely that how the wastewater can be recycled and it can be refined and pollution can be removed and it can be used. It should be taken into consideration in the water management. Like that wetland management, it is also a part of water management. Problematic water, like acid soil, acid water, sodic water, saline water, alkaline water, all this contaminated and polluted water should be rectified and should be used and taken into account in the water management. Water management, lowland area, watershed area, water trace, dry land agriculture, soil water conservation options, organic manure options, organic agriculture, hydroponic, and particularly virtual water. This virtual water has got a great role to play in water management. What is the virtual water? Virtual water which we cannot see. You will be astonished to find that every production has got a measurement with the footprint. It is being measured how much water used for the produce 1 kg of rice, how much water required to produce 1 kg of rice. You know, there is a some colloquial idea that if the 6-ton variety or 6,000 liters of water will be required to produce 1 kg of rice, it is much of water, much water. Like this, so many things are there which is water required, much water required. In wheat, 600 liters of water required for 1 kg of wheat. But in rice, much. These are called virtual water. So it is no point of discussion, but I am telling you, it should be considered in the water management, effective planning for water management. All these things should be taken care of. But what happened with the hydrogrameen technology? When I heard from hydrogrameen technology, it is also a process of injection of water to the underground, because to increase artificial recharge or it increase the water level in the underground sources. It might be required something like impervious layer or not penetrating or something, maybe hindered like that. It has been discussed in the some time before. Some presenter discussed it. So we have to think it. But hydrogrameen is a technology by which we can inject water and we can increase the groundwater sources, underground water sources. That we can increase it. So this is in our system also. There are some system, indigenous system like well or some increase the actually renovation and regeneration of a farm pond and other thing. We are keeping water for a long time and it is being recharged artificially through the underground. So underground recharge of water, it is a process. Hydrogrameen is like that. So far I understood. So it has got great implication to agriculture. Agriculture is the main stakeholder of water use. And agriculture, 78% of the total water resources are being used in agriculture sector. So we are agriculturists or agricultural planner or agricultural activists. They should think of more precious way how to use water and how to recharge the groundwater, that it cannot be short. It cannot be short, it cannot be make hindrance. So nowadays actually it is correct that underground water is, we are losing underground water because extraction is much more than utilization or use. Extraction is much more than the recharge. Extension is much more than recharge. So we have to increase recharge at any cost. That may be natural way, that may be artificial way, that may be some way, but we have to recharge the groundwater. And groundwater is the source by which we can make the water resource availability more and more. And another thing I want to tell you here, that water has got a great nexus with the poverty elevation. Where there is water, their poverty is less or poverty is not there, almost not there. Sufficient amount of water is present in the locality, that poverty is less in that locality. And where the water is shortage, potable water or agricultural water or water is shortage, then the poverty will come. So many with the social problem. So many social problems. In India, we are seeing it. Where there is no water, the problem is much. And the area is uncivilized and underdeveloped. But where the water is available, so poverty elevation is a means, water availability is a means by which you can elevate poverty. That's the indication. So we have to make it available. We have to make it available. Poverty is our crime, it is crime, and poverty, we have to elevate it at any cost. So we have, as a means of groundwater recharge, this hydrogrameen technology is boon for us, thanks to inventor Dr. Raspberry Ghosh, when he told me that this is the type of injection or reservoir, recharge the reservoir, underground reservoir. Then I take it very seriously, and I was in the Centurion University of Technology Management in Odisha. I told the authority, and they agreed to make a international conference, symposium there on hydrogrameen technology. And I made it 2 years back in Odisha. So we want to popularize this technology. That was the main issue. And today also, it is our main motto that wherever it has been invented, but we have to take it seriously and as a measures to recharge more and more groundwater. Now, I am telling the role of agriculture in natural disaster, like I can say the COVID-19 has come in our country as a natural disaster. The whole world is suffering. We are also suffering. We being developing country, we are suffering most. Most we are suffered most. And what happened? This effect of this hydroponic, the effect of this COVID-19 first hit the market and farm price of the product. Actually, what happens? All on a sudden, lockdown was declared, and there was no way at that time. They did not get any way how to eradicate this severity. So in the month of March, lockdown started. Still now the effect of lockdown is going on, but actually it is phase-wise, it is reopening all the things. Lockdown effect, lockdown is reopening, and we are now we are opening the lock. Okay, the market price and farm price destabilized because it's due to communication or road blockade or all the thing that farmers cannot approach to the mandi and cannot sell their produce, and price locality somewhere it has been very high, and somewhere the price of the common agricultural commodity, it was not very high, it is very cheap. It is very cheap. It was very cheap. So this is the destabilization of market and produce price or farm price. Because of it, supply chain has also been destroyed. Only local produce, the local farmers can take it. But as because agriculture was a stronghold in agriculture, actually we did not suffer much. Otherwise, in other advanced countries, they suffered from the supply chain. They are not getting supply. So supply chain slowdown and shortage has been seen. Farmers' health. Actually, farmers are the backbone of our country. They are producing, they are toiling for us. So the farmers' health is becoming a question in this period. And farm workforce, it is due to farm workforce. Actually, you know the migrant labor from different part of the country. The peoples are going, farmers, the peasants are going to here and there throughout the India. And when the lockdown started, they shifted from their place and tried to come back their own home. And the workforce and the locality where they were working, it was very much disturbed. It was very much not only disturbed due to this all on a sudden lockdown and gave some scope to go back to their own home. The huge casualty has been arrived, huge casualty. So this is the farm workforce and their problem. And the what happened in lockdown period, we need some people safety, farmer safety, personal protective equipment, PPE, that we need, but sufficient amount I did not get. Another difference, so many disruptions causes, and we faced it. So fortunate enough in case of India, that everywhere, every sector, the GDP, gross domestic product, has been declined too far, and economic devastation or economic loss and the reflection in economic, it has come in India very severely. So GDP reflected minus up to last 3 months before, it was minus 23.7% GDP. GDP means the total production divided by total cost of production. This is the GDP, the ratio is called GDP, and it is the index of development of a country. So GDP in India was beginning to decline from 1 year, 2 years back. But now due to COVID, the GDP declined fast, and we got to minus 23.7% GDP. But at that time also, the agriculture got positive GDP, 3.4 or 3.9, like that, 3.9 GDP. So agriculture sector has not been affected so much, only some other difficulties or problems, but agriculture stronghold in India is very good, and farmers' contribution in agricultural the economics of a country is much more stronger than any other sector. So every sector has got negative, only the other than agriculture sector. Nowadays it will improve. Last 3 months, day before yesterday, it has announced that it is 7 point something overall minus. Overall minus GDP is 7.4 now. But it was before 3 months, it was minus 23.9, like that, around 24% GDP minus. Now it is minus 7.4 or 7.9, like that. Nowadays, a day before yesterday, it had been announced by the Finance Corporation or the Reserve Bank of India. So, whatever my intention to tell the audience, the participant, and the panelists and others to think it, that agriculture should be developed in such a way that we should give good boost up in the rural reconstruction or economic reconstruction in the country. And it is the only way by which you can do it. Only way. Agriculture is the only way by which, because our country is agriculture-based country, we cannot move to industry, though agriculture is also industry. If we take it that way, that agriculture also, the agriculture also should be considered as industry. But our country, most of the farmers are either landless or small farmer. In West Bengal, you see, it is most of the farmers are landless. 52% of the West Bengal farmers are landless. There is no land. They are putting their own labor, own work, and their another farms, another ownership. So they are not own farm. They don't have own land. In India also, this figure is a little bit high, but their farmers, landless farmers is less. In West Bengal, it is much. In Odisha, Bihar also, like us. But Punjab, Haryana, the other thing, they are other state. They are very high. They are high farmers with landholding. Maximum landholding is there. So nowadays they are ongoing their movement regarding the some Farm Act has been pronounced recently. So they are fighting to resist it, because they feel it. If the mandis and other things go to corporate house, then they will be loser. So they are fighting for it. It is not matter of us. But I am telling you, agriculture should be free from all such incumbents, and it should be moved forward. If the country to move forward, agriculture, we have to take much care with agriculture and agricultural peasants and agricultural laborer and workforce. We have to take account of it. And due to COVID, we have to overcome the COVID-19 effect anyhow. So I think it firmly that hydrocarbon technology that can be a boon to give more water resources in underground and to give more water supply for crop production, intensive cropping, and more crop production. So we can get rid of this situation and we can reconstruct our economy. Another thing I am telling, and I am finishing I shall finish this small brief. That is, you see the farmers are thinking on the farmers' way, but technologists and whatever we are thinking for science and development. So we think agriculture is the way, because I told you, one out of 135 million people, 120 million small landholder in our country. But 40% of the country's production is coming from these people. So they cannot go to London, they cannot go anywhere. They have to sell their produce here itself. But though there is a problem of middlemen and other thing is there in agriculture, but we have to remove it. So due to COVID-19, whatever bad effect we got, we have to get rid of or remove all these bottlenecks or difficulties by the development and advancement of agricultural situation for more precious use of water and judicious use of water, surface water and groundwater. Surface water is much more palatable and much more quality is there for surface water. But surface water we cannot weigh to reserve there's excess surface water due to the excess rainfall whenever we are getting. That is being wastage. So dam and reservoir, whatever we have done in British era, we did not make so much dam or so much except Hydrogrameen and except some in other states. In our state also one has been done, but not much work has been done in the renovation or the reclamation of this capacity of the reservoir. So we cannot store it. But the watershed concept and other thing has come by which we can not only reinject the excess water, rainfall water to the ground underground, but also it is the way to make second crop during the Rabi season, winter season, or summer season. We can make another agricultural crop. So if we produce more and more, it will be the boost for us, because you know, when the Bengal famine came in 1942, it is not the people died, some lakhs of people, 10 to 15 lakhs of people died, not of the availability of food, but the supply of food. Supply of food, only the supply of food, it needs attention that food is available. Still okay. Okay, I'm finishing. So this is the agriculture that by which we can make this that easier, and hydrocarbon technology may take a role, vital role in this manner.
Thank you, Dr. Zaman. Thank you.
Okay.
Thank you very much.
Okay, thank you.
It was really,
thank you.
It was
and
really a great thing.
And thanks to all audience, and thanks to the panelists, and thanks to participant who participated. Thank you. Thank you very much. I have another business, so I may kindly be excused for 1 hour. So I shall again join before the.
Okay. Thank you. Our next speaker, Rosalie, can I have the slide, please? Yeah. Our next speaker will have a special presentation about our rainforest, which is also very timely as we continue to see the destructions of rainforests globally. And we see the consequences of our actions as it impacts our environment. Mr. David Seaborg is the founder and president of the World Rainforest Fund. He is an evolutionary biologist, poet, and also wildlife photographer. So let us welcome Mr. David Seaborg, and he's going to speak about destruction of Earth's rainforest causes, consequences, and solutions. David Seaborg.
And thank you, everybody here. It's great respect and love that I'm here speaking to you, and the folks in India, good morning and good evening here in the United States. I was in India on a trip couple of years ago, and it was one of the greatest experiences of my life. And I am assigned largely to speak on rainforest. However, this is a water conference, so I am going to emphasize in my talk not just rainforest, but well, it will be rainforest, but it's going to be linked to the water cycle since this is a water conference. So the rainforest, and if you want to know more about the rainforest, you can learn that in the nonprofit organization that I am president and founder of. Is the name of the fund is the World Rainforest Fund. That's the nonprofit, but the website is worldrainforest.org, worldrainforest.org. So if you want to know more about rainforest, that we save rainforests by empowering indigenous people, but it won't be just about our work. That website is informational all about rainforest, why they're being destroyed, and so you can get a lot more on there than a 20-25 minute talk that I'm giving you now. Now, the rainforest is being destroyed at about the rate of year, cut and burn, and that is about 300 acres per minute, and it's being destroyed because of getting the trees for lumber, also to cut the trees and plant grass to grow cattle for hamburgers, also to go cash export crops to grow them, such as coffee, bananas, and so on, and also to build mega dams which flood the rainforest. And here is a water issue, the misuse of water, because the mega dams kill off acres and acres, hectares and hectares of rainforest because they flood the rainforest. And this is particularly serious because of its effect on climate, which is that normally if a rainforest is intact, it helps solve the climate crisis because through photosynthesis, trees take out the major greenhouse gas, which is carbon dioxide. On the other hand, if you cut or burn a tree, their decomposing from being cut or their burning gives carbon dioxide into the air, and so you make global warming worse. Now, if you flood it with a mega dam, such as being done in Brazil, Peru, the Amazon basin, and Borneo, then you have other organisms decomposing the trees in an area underwater where there's no oxygen. So it's anaerobic organisms called methanogens, and they produce methane. So in that case, you produce methane instead of carbon dioxide, and then you get a greenhouse gas that is methane, which is 30 times as powerful a greenhouse gas, molecule for molecule, as is carbon dioxide. So damming and flooding the rainforest is more serious with respect to climate change. And also the other reason they're being destroyed is mining for gold and iron and minerals in the rainforest. Now, when you cut the rainforest, here's how you affect the water cycle. Trees create rain through a process called evapotranspiration, which means they take up water from the ground through their roots. It goes up by capillary action up their trunks, through their leaves. They use the water, but they also expel it through their leaves into the atmosphere. So the Amazon basin, the largest rainforest in the world, does get half of its rain from evaporation of the Atlantic Ocean and the winds blowing the water on it as rain, and the other half is produced by the trees through evapotranspiration. So when you cut the trees or burn them or flood the forest and destroy the trees, you lose the moisture. So locally, that means you get droughts. So that's a local effect. You get droughts. within the rainforest, which is serious because people, small-scale farmers near and in the rainforest can't produce food. But secondly, it's serious because it kills the rainforest itself, because the forest is too dry. It needs the rain that it produces. And when it's too dry, then there's more death at the edge of the forest, which is the driest. And as the trees at the edge die, there's a new edge, and that dries out and dies. So the forest starts to die from the edge inward, but also it burns. Rainforests normally only have small fires because they're so wet. But if you cut and burn the trees and there's no evapotranspiration and there's drought, you get major fires. So now we have major fires in Brazil, African rainforest, Mexican rainforest, in Indonesia. Indonesian fires have caused major pollution throughout Southeast Asia. So the second thing in the water cycle is the rainforest actually makes rivers, not only on the ground, not only, for example, creating through evapotranspiration, the water going to the Andes and replenishing the glaciers of the Andes, which then melt and then give the Amazon River full of fish, high biodiversity, more fish in the Amazon River than the entire, or as many species of fish in the Amazon River as in the whole Atlantic Ocean, high biodiversity, but without replenishing the Andes through evapotranspiration from the rainforest because it's cut or burned, then there's not enough runoff from the Andes to supply the Amazon, and the tributaries start to dry and the fish die. So that's the rivers on the ground. But there are actually rivers in the air that are even bigger than the Amazon River. So these are generated by the evapotranspiration from the Amazon. And these rivers, they go beyond the rainforest. They go out of the Amazon into an area known as the Pantanal, which is the largest wetland in South America with very, very high biodiversity, that is, high number of species. And much of the water of this wetland, called the Pantanal, the second biggest wetland in South America, is supplied by these atmospheric rivers. Now, when you cut the rainforest and you lose the flow of these rivers, or at least you lose some of their moisture, you get dryness and a loss of the wetland and a loss of the diversity in the Pantanal. You also have these rivers of the air, atmospheric rivers, supplying water to farmers down south and out of the Amazon, and they lose the water. And in fact, even beyond these rivers, there has been studies now that have been shown that when you cut the Amazon and lose enough of it, the models have shown that you actually get drought and even changes in the temperature in places like Texas and the Pacific Northwest up in the United States. Far from the Amazon, cutting the Amazon, you affect the hydrologic cycle up in North America, in the United States. These rivers, by the way, that are in the atmosphere are not limited to the Amazon. There are major atmospheric river systems that carry water in Africa from the Congo Basin rainforest and also from the Southeast Asian rainforest. Now, I want to talk a minute. So I want to make the connection here between climate and rainforest, because if you have global warming and climate change, then you get drought in the rainforest, quite independent of the trees themselves. You get drought because it's hotter and drier at the equator, so you get less rain, in addition to what I just explained about evapotranspiration. So you get dryness and therefore more fires and this death of trees from the sides. Now, this is serious partly because half our medicines come from the rainforest. medicines for example, heart disease, cancer, fungal diseases, malaria, and many others. Half the medicines are from rainforest. Many of our crops are from rainforest, Brazil nuts, coffee, cacao, etc. And also the rainforest has half of the species in the world that occur on the land, half of the land species. So it's the highest number of species, the highest biodiversity in the world. So these are, and also it's a source of food crops. So, and it also regulates global climate. So when you lose the rainforest, you also, as I explained briefly, but we'll go into a little more detail, you also cause global warming to be worse. So if global warming is because you cut the trees, they no longer are taking carbon dioxide out of the atmosphere, they're adding it. You're turning a living tree, which is an ally, to a dead tree that's cut or burned into an enemy that's producing carbon dioxide. So now you're making global climate change worse. Now let's look at the effects of the rainforest and also, you know, other things, just adding carbon dioxide and methane to the air. How does that affect this effect of what we're going through in climate change? How does that affect the water cycle, which is related, as I pointed out, to the rainforest, but it's also burning of fossil fuels and so on. Well, that is the major way that affects the water cycle is that the glaciers in the mountains, not the ice caps at the poles, but glaciers and mountains melt more quickly because it's hotter, and they are not replenished by the normal cycles. So we have the Rocky Mountains losing their glaciers. Mount Kilimanjaro is losing its glaciers. Glacier National Park is going to have to change its name. These glaciers support and feed rivers. Now, more serious than that is we're melting the glaciers in the Andes that feeds the Amazon and other rivers. But most important, we are melting the glaciers of the Himalayas. And the Himalayas support 7 systems, including the Ganges River, the Yangtze River, and the Yellow River, that support over 2 billion people in several countries: Pakistan, India, Bangladesh, China, Vietnam, and other smaller Southeast Asian countries. So when you melt, now normally the glaciers in the Himalayas melt at a certain rate and they replenish the rivers, and then they are replenished by the natural water cycle. When that water evaporates, is carried by wind, and falls as rain onto the Himalayas, actually as snow, and replenishes the glaciers, which melt and then feed the rivers again. So it's a hydrologic cycle. But water is held, more water can be held in the atmosphere if the atmosphere is hotter. If it's colder, it drops out as precipitation, as rain. So as you warm the earth, that water, the air is hot enough that it does not again fall back onto the Himalayas, and the Himalaya glaciers melt faster. So in a matter of decades, if we lose the Himalayas, imagine the effect on first the forests and all the biodiversity, the river systems and all fish, frogs, amphibians that live in them, but also the needs of over 2 billion people in India, China, and so forth that need that water for drinking, for their forests, for their food crops. So that would be the most serious effect on the hydrologic cycle. Now, I want to say something about the sea, because when we talk about water, we always think of the fresh water of the land and the atmosphere. But the saltwater system is also very important. And the cutting of rainforest and exacerbating global warming, and also adding the greenhouse gases and exacerbating global warming, affects the ocean current cycle in the following way. Up in Greenland and up in the Arctic, the ice there, the Arctic ice caps, they melt as the climate gets hotter. Now, as those glaciers on Greenland, the Greenland ice, the Arctic ice melts, what this does is it adds fresh water to the salty ocean. Normally, that water being salt is more dense and sinks. When that water sinks, it causes the currents of the earth, including the Gulf Stream. Now, this Gulf Stream actually goes down along the United States and then back up along Europe as warm water. And the wind blows over that warm water and picks up heat and heats Europe. So the atmosphere and the ocean currents interact. But Europe is only as warm as it is, and has the Mediterranean climates in places like Rome because of the Gulf Stream. Rome is in fact at the same latitude as Chicago. The reason Rome has a nice mild Mediterranean climate like California is the Gulf Stream. So as you melt that ice in Greenland, the water no longer sinks because it's not as dense, because it's not as salty, because it's getting fresh water. And so the Gulf Stream could shut down. More seriously is in Antarctica, which there is a 2-mile deep trench off of the coast, just off the coast of Antarctica, where 1 trillion gallons of salty brine go down every year, and it's 500 Niagara Falls every day, rather. They plunge downhill into the Weddell Sea. Excuse me, not every day. This is 1 trillion gallons per hour, 500 Niagara Falls per hour. Go down this deep chasm off Antarctica. So it plunges down into the Weddell Sea. The salt water, it runs like this. First, the salt water freezes because it's very cold in Antarctica in the winter. Makes small crystals. Small crystals grow and they knit together. These crystals then bond. When the crystals bond, they expel salt, and that goes down long, narrow tubes into the ice. And then that makes brine, which is very salty. That is dense, denser than the salt water. It sinks. It's cold too, so that makes it dense. Cold water sinks, hot water rises. So it sinks, and you get 2 billion tons of ice equivalent per year in the Weddell Sea. And that is, so tens of trillions of brine going down. And that is the system, that sinking, that runs the currents of the entire ocean, which are so important to heating, to distributing the heat of the earth so that the earth's temperature is more regulated. Because of the ocean currents, which go around in a cycle that takes a long, long time, centuries to finish. But this is what makes it, because it's this constant movement that makes the Earth's temperature regulated, because it takes heat from areas of hotness to areas of coldness and stabilizes and balances the Earth's temperature. And it also is a major transport system for everything from sharks to sea turtles to phytoplankton in the ocean. So it's very important to the life of the sea. So that, I just wanted to add a little bit of the water cycle in the ocean and its importance and its connection to climate change and rainforest. All these systems are interrelated. I see that I've been here 20 minutes now. So let me kind of wrap up. Well, but I don't want to forget, since we are the Bengal Basin Institute, and we are talking to people in India, and we are talking about Bengal Basin, that the one of the things that climate change does, as you know, in melting the ice caps, it causes the sea level to go up. Secondly, many people don't know this, it's the heating of the water makes water expand in volume and take up more space if it's hotter. So the ocean also rises because of the heat added to it, making the water expand. So many areas are going underwater in time. In fact, they've already started. That will include Los Angeles, San Francisco, Florida. Miami already regularly floods regularly. It'll include London and Tokyo, many Southeast Asian cities, and it will include many islands in the Pacific, such as Vanuatu and the Marshall Islands, which are already going underwater. But I wanted to emphasize here that Bangladesh is already starting to go underwater and losing its coastline. And this is causing a problem with people in Bangladesh going to India because they are losing their land, and there are already too many people in areas of India, and this is causing another problem. One problem leads to another, and in fact, already now, there are more environmental refugees in the world than any other kind of refugee, including war. So this is a very intense international problem, causing tensions and taking away people's area to live. And it is also a problem in one very important ecosystem in the Bengal Basin, in India and Bangladesh, the Sundarbans, which is a very important wetland home to tigers and tremendous biodiversity, which is under threat for other reasons, to be sure, and must be protected, but also is under threat of being flooded from the oceans rising. So I'll leave it at that. You can always, I'll be on the panel. I'm here to answer questions if you like. And again, if you want more information about rainforest, it's worldrainforest.org. And if you want to give us a donation for our work, you can go there as well. I thank you for your attention. I thank you for your attention.
Thank you, David. Thank you. It was really wonderful. Thank you, David. It was really wonderful. And we were really honored by your vast presentation regarding the rainforest and also its link with the water crisis and all those aspects. Now we are actually waiting for our keynote speaker, Dr. Kamal Kaur. So he's having a small problem joining the meeting. So just please bear with me, audience, so that he joins it. Just a second. I think he's trying to join us. So please, yeah.
So maybe we can ask Dr. Tapash Bishash to do the wrap up.
Okay.
For the speakers, and then I'm trying to help him get into the webinar.
Okay. Thank you, Rosalie. I would request Dr. I would request Dr. Bishash. So far, please wrap up the session. Dr. Kaur is trying, so unless he joins, we cannot hear him. So please wrap up the session so far.
Well, I'm happy to do that, but I was just wondering if he cannot join video link, can he join via phone, and maybe he would like to speak for 5 minutes to give his ideas to us, and that might help us concluding the session. But if you think that we
No, I think we better wrap up now. Then in the meantime, when he joins, in case he can join, then we can go ahead about it.
Yeah, yeah. I'm also mindful of US time now.
Right, right,
This
right, right,
is right in the middle of the night, I'm sure.
right, right, right.
Okay, so it's been a very productive and I would say a lot of knowledge shared, ideas exchanged, quite enthusiastic presentation about water, the core foundation of our own survival, of our own body as well. So I would like to share my few thoughts, and I'm so happy that Professor Seaborg is here, and he had a deep love for India. So that's very nice hearing, and Dr. Seaborg. But I am an Indian, but I live in Australia for more than 2 decades, and we'll talk later probably via our email system. So let me share some of my thought. Now, are you able to see my screen?
Yes.
Fantastic. Ooh, that's not what I wanted. Okay, is that something you can see now? Can you see my screen, please?
Yes, we see.
Yes,
Yes.
we see.
Wonderful. Okay, so as I said, I was struggling that, how do I start wrapping up? And I really don't want to take a long time, but my main idea is that water has been in 8 of the 17 sustainable um, development goals that set by UN, and out of which goal number 6 has got a very clear um, instruction about management, sharing, and improving the quality of water um, among us. And you can see here that the global as a whole have got either in stress condition or in an acute state stress condition in many parts of the world when it goes to renewable water resource usage per capita. And Professor Seaberg, I am I'm really indebted to your wonderful narration on how the rainforest can play a role in this water conservation world. And also, I would like to go back to our previous speakers. For example, Dr. Kaur, who has spoken clearly, given us a bit of warning about the groundwater that are being happening in India and particularly in Bengal. And if we don't, we know this problem, we know arsenic problem is going on for decades. But this is the time, if we don't put enough political will, a support, a willingness to do something, the things will get worse. And when the things get worse, probably we won't be able to reverse the damage that has already caused or will cause in very short time, given that the climate is changing, the globe is getting warm, um, deforestation is still continuing, and population, of course, is increasing. And if I want to talk to you about water, I cannot um, uh, stop without sharing this, that if you look at beginning of this century and today, the water usage has been increasing steadily, in fact exponentially. And if we don't do something, uh, this will not lead us to anywhere. Only it will lead us to desperation. And hydrogrameen has got its own uh, pros. It might have some cons, but the pros are more, and we might get some of this water resource problem and issue sorted, both for surface and for groundwater. But who are the driver? Why are we ending up at this point today? Simply because the population growth outstripped the supply. And then with the wealth, particularly in those developing countries, those who are very poor, couple of decades ago, they have seen more money now, and they are buying better food. They are going for better life of water. Better food, better life of water needs more water. You know that 1 kg of beef, 1 kg of meat, 1 kg of grain, 1 kg of milk to produce those commodities, we need lots of water. So this wealth and population, water shortage, they have all nexus, and of course the energy within that short. And then the I beg your pardon. And then the other one that I was going to share with you is this, that whenever there is a water scarcity, there is water pollution problem. And I have done a little study, and I found out that from Himalaya to the south of India, 600 million people are suffering from water scarcity, out of which 200,000 people are dying either from direct water pollution related cause or indirect water pollution related cause. So this number are humongous number. This number are quite warning number. And hence I must commend to all my predecessors who spoke before. They have such a passionate interest in managing our limited and scarce water resources, finding alternate solution, using water in a different way, innovative way, in more sustainable way. And I think those are the things that we have been talking for many, many years, and it's taking time. So the question comes is awareness. And many parts of our world, we lack awareness. We lack communicating to people that how precious the water is, whether it is Ganges or Yangtze or Amazon, or even in many developed countries, many rivers, they do suffer from time to time from different issues. So this awareness is so powerful. Getting people in action is so powerful. So we need more and more people, coming and joining to this idea that we make our globe better, from the water resource point of view, both groundwater, surface water. We also need to care our ocean, because I have heard that ocean has so much of food, they can feed us for many years. And these are the things, I guess, are so important in our equation. And things are happening. I must not say that it is all gloom and doom. There are hopes, there are actions happening, there are environmental groups, there are NGOs, there are government willingness, there are political willingness. People are getting more and more into pressurizing the system, pressurizing the politicians to do something about these water resources. And I cannot stop saying that Australia is one of the forefront country when it comes to environmental movement, environmental solidarity, and using this people action into environmental solution finding ways and paths. So with this, I would say that we need more work. Our road ahead is not rosy. Our road ahead is quite upheaval with a lot of ups and downs and bumps, but we need to work together. We need to get more people thinking similarly as we think, finding solution out of the box. So if I'm kind of comfortable with my own technology, I should not think myself that this is the only technology, and I've been so fortunate hearing from different people, and you know very well that Singapore is the country they uses almost all of their sewage water. They treat them, and some of them they make to drinking water quality. And in true sense, any water on earth is a recycled water. So the wastage, mismanagement, lack of awareness, lack of political willingness, lack of funding, and lack of encouragement to sustainable water management still are those causes that are not helping us, getting us to use each drop of water more efficiently and effectively. So my friend, with this, I would like to again thank you so much for sharing your knowledge. And also, I encourage you that we all work together with all our willpower and thinking and our technology in our quiver, all the arrow that we have. How do we realign them to help site-specific, community-specific solution? And hydrogrameen is definitely one of them. The concept is not new, the concept is old, but how do you design the old concept in a new framework, in a new societal arrangement? And I must tell you, there are movement happening throughout the globe. It's called smart city, and smart city is all about around the water. So water is the center of any smart city that are being proposed or will be built, and those smart cities will be using each drop of water so intelligently. So technology is there. We have done enough research. We know a lot of things, but we need to put this together into action. And with this, I urge each one of you, including all the participants, to think and to act in a holistic manner and act together to find and implement solution. Finding solution is not alone. We need to find champion to implement them. Unless they're implemented, they will be all written on the paper and will be on the shelf. We don't want that. And I definitely am so happy that we have such a group of energetic people who would like to give their time volunteering for this particular water cause. And with this, I would like to conclude our session. Thank each and everyone for your time. It's been quite late, and I'm really sorry for a few technical glitches, but at the end, all well that ends well. Goodbye and good luck, my friends.
Dr. Vishwas, thank you for wrapping up. But we have certain question answers in the Q&A. So if that could be answered to the audience now.
Thank you, Rupsa. I did answer some already, which was pointed towards me, but I think my other colleagues need to look at them and reply some of the question. One question, Dr. David, one question was COVID, how COVID influenced our water resources management. So maybe we do reply them through the chat box as Jason suggested. So we don't need everyone here. We can do that. Is that okay with everyone?
Okay.
So I must also thank Rupsha, Ras, and Rosalie for so meticulously putting this program together. And look, it's a sincere thank you.
Thank you, sir. Thank you.
Okay,
Yeah, Rosalie.
Ruksha, can you, okay, maybe Dr. Tapash can stop his screen sharing. Okay, maybe we can ask, we can request Dr. Devnath there to speak something about, you're talking about desalination or making a comment, right? Okay.
I just want to talk about little bit about what I learned from you guys, and also in my experience and reading with Dr. Ghosh. Um, so I just want to talk about that. This is a very important and burning problem for the whole world at this moment. And what I understand from that, what I understand that, sorry. What I understand that going on that Hydrogrameen is one of the important project, and is basically coming the it's a low cost and also low hazards. Um, that is why it is extremely important for us to proceed with the Hydrogrameen project, or that, and also we need to consider the desalination. Desalination project is extremely important at this moment because it will remove the, it will cause the huge remedy for our water problem. And there are Berkeley professor Richard Sikali is working on that aspect. Rash already talked about that, and using graphite and other filtration related device or strategy they are using to remove the salt and making the water purified and use that. So in summary, I just want to point out a couple of things that, which is extremely important, that we need to remove the fecal matters from the water and from the aquifer, and also clean the water and toxic substances from the water, so that water will be going into the aquifer, into the ground state, so that the water which will come out into the later on, that will be kind of very clean water. And what the fecal matter we can use for agriculture purpose, but we need to clean the water, number one. And number two, we need to have a social awareness from within the different country, especially India, Bangladesh, and some other countries. That will be helpful. That's all I can say to you guys.
Nasima 4 projects in Bangladesh.
And Nasima did a very good project in Bangladesh, and 4 different projects. And that is a kind of very successful project.
2
in
billion
the
gallons
2 million gallons 2 billion gallons enter into the aquifer. So it is a huge success from the Dr. Ghosh. And it is actually happening in Kishoreganj, and Nasima and other people actually deliver this project. Dr. Ghosh is highly successful on that at this moment, but he wants to spread out around the globe, around India and Bangladesh, more places, not only Kishoreganj. That's the thing we need. We need more funding, we need more research, and we need government funding for that. That's all I can say. That is a comment from my part. Thank you very, very much. It is a really useful meeting that I can say to you. You want to talk?
Any question, Rupsha?
There are a lot of questions in the
Okay.
One of the question that was submitted very recently is what is the best way of artificial recharge?
Artificial recharge.
Right.
That's what they're doing. This is an artificial part of artificial recharge.
So what is
And
the
a
best
part of
way?
that is the best way we know. And I think Dr. Bishwas mentioned that the concept is not old because recharge is a natural phenomena. Percolation is naturally occur in a lot of places are naturally recharged and hundreds and thousands of years. So maybe he can cite some example, which is probably 100 or 800 or 1,000 years old. We have something is going on in India or Australia that I don't know. I want to have some information from any sources available. The artificial research.
May I, sorry.
Go ahead, please.
No, there is a David. David is raising his hand. David, you first. Your microphone is on mute.
Mine?
No, David.
David. Okay, so fine.
Okay, when David is fixing things, artificial recharge, and I'm sure Amlan knows that very well, that CSIRO did lots and lots of work on artificial recharge. So it's just simply putting back water into the aquifer, whether it is shallow or fractured aquifer. Dr. Kort, do you want to say something about that?
Yes, actually, as regards artificial recharge,
I'm demuted.
generally it happens both from it can be done through in the landscape as also in the urban areas, especially. It is also discussed in our during our deliberations. Some of my co-speakers told about the. I think in the very first lecture, it was pointed out that quality of water is also a very big issue. Quality of water, what we are actually injecting into the aquifer, we must be quite aware of that, what we are actually injecting. That is also one of the issues. So especially in the urban areas where there are chances of getting polluted water. So in that case, we must be watchful that only rainwater, at least in our countries like India, Bangladesh, etc., rooftop rainwater, and that should be recharged through mostly through tube wells, because aquifers are generally underlying somewhat below the ground level. That is the artificial recharge from rooftop through tube wells and bore wells. That is widely in practice in India, in many parts of India, but in West Bengal it is yet to be started. We have done few pilot works. And in landscape, of course, landscape, as already it is discussed by you, it is discussed by many others. It is also naturally happening. Suppose, as I was showing many of the pictures, like check dam, then ponds. If these are those are actually constructed in huge number, and from these I mean structures, we can harvest huge because from roof we cannot harvest adequate quantity of water. That is rainwater, but actual water, rainwater surplus, monsoon runoff, especially in the countries or the states like West Bengal, Bangladesh, we get huge quantity of rainfall at least. So those surplus rainfall, if those are actually
Dr. Kor, I'm sorry to to interrupt, because we are running very late. In
that way, from landscape we can.
My simple point is that artificial recharge has been going on for millennia. Any pond that people have dug, there is an artificial recharge. But recently, that concept has been taken into commercial world. For example, treated sewage effluent. You can put lots of this into the ground, and then they get cleaned there, and then later on you take out and use that for irrigation or other purpose. So maybe that person who asked that question, Rupsha, if he's happy with this answer, I would suggest that just to type www.csiro.au/artificial recharge.
Okay,
I
so
am now,
I have to add
excuse me,
something
Rod,
to that.
excuse me, Dr. Ghosh, 1 minute. I'm actually unmuted
Okay.
now, so I can make the point, which are two. One was somebody asked about COVID, and I didn't hear the whole question, and I thought they were asking me, so I'm not sure. So I want to know if about that question, if it isn't answered and I'm supposed to answer it. But as far as the artificial recharging of aquifers, I think there's one thing that we don't need to overlook. We must take into account, which is that we need to keep the aquifers preserved in the first place, not just artificially recharging, but not losing the water in the first place. And that is the main gist of the problem, because the use of agriculture is draining aquifers all over the world through irrigation. Secondly, climate change and causing drought and evaporation, and also the dams are all drawing from aquifers. And it's to the point where now cities all over the world, a good example is Jakarta, actually sinking. So the Edwards Aquifer in Texas, aquifers here in California, they are drained largely because of human use, and that has gone up exponentially over the years. So of course recharge, but recharge will not be enough or the main solution. The main solution is we have to stop the overdrawing of water from the aquifers for irrigation and other purposes, and we have to save the forests, including the rainforest, and we have to stop climate change and stop building the mega dams.
Oh, over to Dr. Ghosh for his points.
Yeah. Artificial recharge can be considered through pond percolation, but even then, if some impermeable layer underneath the pond, then it always goes horizontally, and it takes months, years, and maybe 10, 15, 20, 30 years. The artificial recharge is effective, then we would not lose about 2,200 important aquifers in the planet. We would not face a water crisis. We would not lose 30,000 feet of storage space of San Joaquin Valley, the richest country in the world, richest technology, money. Nothing could help us to save San Joaquin Valley, one of the largest agricultural producer in the planet, or the largest. The artificial aquifer restoration become a vital, and based on my 12 superfine toxic sites management with California a couple of decades ago. So I think the artificial recharge, Bangladesh has a 240,000 ponds in 1960. Now it has become close to 1 million ponds, and still Bangladesh is facing a shallow water crisis for agricultural purposes in many parts. Even 1,000 feet deep, the production aquifer in Kumilla is getting dried. So this is very disjointed way of working. When you put it together, then it looks like then we have to change our title. There is no global water crisis. For example, Kolkata groundwater exhausted started close to mining 1965-70. Dhaka groundwater has been started mining, close to mining 180, according to persons, a consulting firm who did the study on Dhaka groundwater. The Dhaka groundwater is fed by filthy Buriganga River, where I part of my life, and it is still feeding, but polluted water. The Dhaka people probably use groundwater much more than the Kolkata, because Kolkata use Palta and Tala rivers, which are also very filthy rivers, use surface water, and some portion of it come from groundwater. Dr. Kaur can confirm that or correct it. So that was my information. The artificial research does not or is not working, and artificial research, we are trying to trying to make it better. Yeah, make it better. Once you start pumping water from the surface, it helps accelerate, open up, and make the destructed aquifer being naturally, gradually restored. But until these aquifers are restored, the naturally created aquifers are not used, then we are fighting against the nature. So I think we'll be more than happy to see Tapasda's website and where this information available. It will immensely help us. I can
Yes.
go on and on.
Yes.
I think, thank you very much. Now, Rupsha, I have a special request.
Right.
I'll have to head up. We have exhausted our time.
Right.
And can we just straight go to the question? Do we have how many questions left?
No,
And
we nearly completed question except one.
And we suggested that we will take that on through email. So maybe we do that. Let's not answer each and every question.
Right.
How are we going to share emails? Is there going to be a list, Rosalie? Is there going to be a list?
Yes.
Right. Dr. Tapash, Dr. Kamal Kar is already joined us.
People have left. There is no participant. Oh, there are participants. Huh?
There are, yeah.
Okay.
Don't worry about participants.
Maybe you can show your video.
Hold on.
Yes.
Oh, there you go. Share your video. At the bottom there is this stop the video, or
you are asking me to share the video?
Yeah, so that we can see you.
Oh, okay, but if you want to see me, then I'm not properly with the tie and all that. I'm just in a casual dress.
There you are.
Yeah.
So Rupsha,
maybe
you can introduce Dr. Kar.
Right.
Hello.
Hi. It's our honor to actually introduce Dr. Kamal Kaur. Dr. Kaur actually was trying, and so he got delayed in joining the webinar because of some technical glitch. He's an international recognized development specialist and in the field of rural development and national resource management. He's the founder chairman of CLTS Foundation. CLTS have been adopted the mainstream in the national sanitation policy of more than 58 countries. These regions, Dr. Kaur is also a recipient of so many international awards. So Dr. Kaur is basically going to talk on, can we act responsibly and protect the pristine gift of nature, the water? So Dr. Kaur, the board is yours.
Thank you very much. Thanks very much for the introduction. And I'm sorry for being late, and sometimes, on a Sunday morning, it's good to speak in a auditorium which is nearly empty, and there is no one. Everybody has left, it seems, but it's sometimes good to speak to the walls. But I'm sure I can see at least 4 or 5 people. You can listen to this, and it makes me because of this problem. I think I've been told that all the audience, most of the people have left. Doesn't matter.
So for your information, there are 38 participants listening to you.
Okay, that's very good.
Yeah.
So, but I don't mind even with the 3.
Okay. Continue.
Okay, thank you very much. So now my topic, today's topic. Let me come straight to the topic. That my topic is: can we act responsibly to protect the pristine gift of the nature, the water?
Yeah.
And to begin this, I would like to say that a great personality who has done a lot of work on water, international water and everything, and it says, and many people agreed that it says that if the nature has given us safe drinking water, which is 1 jug full of water, we have thoroughly polluted it, and the safe drinking water, we are left with only 1 teaspoonful. So that's the seriousness and the magnitude of the problem. And this is a serious, serious problem. And very soon we are going to sort of spoil everything and almost leave nothing for the next generation. Or you spoil it in one hand side and continue to reclaim it, refine it, make it drinkable, bring a lot of technology, use it, and you know, spend money to repair the whole thing, the damage caused. So, which is both going on. Now, how can we maintain and keep the pristine water, but just by changing our collective behavior and acting responsibly? That's what I'm going to talk about it today, because there are pollutants, you know. I mean, right from the beginning of civilization, settlements began along the river basins, on the river sides, you know. I mean, if you look at all the big cities, you know, from Thames to, you know, on the river Nile and to the Ganges to you know, river Hooghly, Kolkata, and everywhere, you know, the simple reason, because the water, river basin, they provide everything: water transport for commerce, the huge, you know, the field, crop field, and you know, the Indo-Gangetic alluvial soil, you know, the Indo-Gangetic plain, which brought, you know, the most valuable topsoil from the Himalayas, you know, washing the whole country from the Himalayas and bringing in here. So one of the top, you know, the most highly productive landmass and water body of the world is this Bangladesh, West Bengal, this side, you know, and along the different districts and UP and places, you know, because, you know, Ganges flowing from there. It doesn't happen in a place where there are not big rivers, you know, in the Nile, you know, and the civilization along the Nile and all that, you know, you see everywhere. So the river basin, you know, has continued to play a very, very important role, the most important role, not only in supplying water for drinking water and irrigation and everything, but also bringing a lot of things, you know, through flooding and all that, and the topsoil and the rich topsoil that it brings, you know, and washed away from the other parts of the country and the landmass, and it brings to you. So, but the question is, nature gives us everything, but how do we act and how do we use it and behavior? Again, now I'm going to tell you the other side of the coin, which is the great examples of massive spoilage of pristine water by wrong human use behavior. You know, the Thames, the river Thames, once it was the big stink of London, you know, if you all know about it. The whole Thames was carrying shit, and it was smelling, it smelled horribly. And even the members of parliaments in the House of Lords and House of Commons, they used to cover their nose with handkerchief, because by the side of that, the river Thames flowing, stinking. And you know, in Germany, the big rivers, the very big rivers, and you know, they were so heavily polluted. There was no, you know, aquaculture, there was no aquatic life in it. It all spoiled. But then when they realized the Rhine, I'm talking about Rhine, and the Thames, you know, when they realized this in Europe, and there are many such examples, people started working back and trying to reclaim, protect, use this and that. So, and again, it has been brought back to that one. It's very clean, pristine and all that. You know, you cannot do anything. Even there are places where dipping your finger, in Bhutan, you know, I've seen it, that even dipping your finger, touching the river, flowing river water is illegal. You know, you could be arrested and kind of things. You can't just do anything. But here, it's a free for all. You know, in open defecation, shitting along in the river and all sort of things, throwing garbage. and discharging industrial waste to domestic waste to everything, It is a general public drainage system, you throw everything and everything is into the river. And that's it. And the Ganges has been carrying and carrying, but it has crossed long back. It's crossed its capacity, carrying capacity, and everything. So now,
Dr. Kaur, do you have any slides to show?
in fact, there could have been many slides I have, but not at the moment because I'm not prepared. I have to find them out. They are everywhere. They are scattered in different places. But if you would have told me, I could have shown you the slides. I could have shown you the slides, beautiful slides on these things. But I think you excuse me for not showing it because there are a number of points. If I can cover them, then I'll be happy. Because since they are not here at the moment, but I can tell you, I can refer to some of the like one of the BBC video. It's a BBC.
No, that's all right. What I was saying, for the benefit of many participants, it is what we feel, from our presentation, to give some kind of facts and figures, and then you
Yeah.
talk through, because some of the story that you have been saying, they're a very interesting story, but many of them are known. So maybe it would be good if you can focus on probably a case study or your personal experience in changing the way we behave, the way we so far acted, and how do we go in future. I'm sorry, because I've been given this role of moderator and we actually exceeded our time by a couple of hours. So I had to interfere. And please go on.
Mr. Moderator, exceeding that time was not my fault, I think. Because
No, not yours. It's ours. It's our fault. It's not yours.
Okay, let him speak.
It's all right. I'm just trying to tell you that I have been given 15 minutes and I will try to restrict it within 15 minutes. Is that acceptable?
No, you have given 25 minutes to 30 minutes.
No, but then I will try to keep it within 25 to 30 minutes. Definitely.
Okay.
I will not exceed
Let's
that.
keep going.
But I think I have just covered 5 minutes, maybe. All right. If that is acceptable, then let me carry on with this now.
Yeah.
Now, I don't know, I lost the flow or what I was telling. Yeah, but anyway, I was trying to highlight about the development of civilization along the rivers, the river basins and all that. Historically, that is the human civilization and growth and everything all over. And the same thing has happened in our country, in India, in almost all parts of the world. And as I said, when the population grew beyond control along the riverside and everything, and we polluted the river, in developing world and many parts of the world, people realized it, and they brought back to the maintaining the rivers, the quality, water quality, and everything was done. But we have to go a long way here in South Asia and many, South Asia, many countries, many places, many rivers, are not in good shape, definitely. So now again, coming back to I'm trying to remind the topic that can we act responsibility and protect the pristine gift of nature, the water? Let me give an example that, I used to advise and I was associated with Iibhb, the International Center for Integrated Mountain Development in Kathmandu, the UN institution working for the mountains, and the Himalayan mountains and Andes and many others, from where all those main river systems, they're developing. And we went to places up on the Himalayas, and we saw right from the beginning, from where the rivers are coming up, they're forming. You would be simply amazed to see that in Kailas area, which, it's a zone, which falls under, India, politically in India, in Nepal, and also quite a bit large portion in China. But you see the way the Chinese are maintaining it, there, and pilgrims are going, thousands, millions of pilgrims go and visit there. And the Indian side, if you visited, you will see in the night, thousands of people defecating in the open with the light on the head. With the light on the head in the night, you will see that people go there for parikrama. They're sitting in the bush. They're sitting in the open anywhere and everywhere. It's a latrine. But on the Chinese side, it's a serious restriction there. And you can't do that. And the people, even more number of people are going there, but there are toilets. People have to use it, and very, very restricted use. Nepal side also, you will see the mix of these things. So the question is, this brings us to the point that from the origin of the rivers, from where they are originating, and from there, our responsibility and better human behavior begins. We have to start from there, and the government has to be involved in that, and right from the beginning, and the awareness, the general awareness, and the public health awareness, and the collective behavior, that has to be practiced, if required, imposed. So similarly, I'm talking about the religious activity, right on the top of the Himalayas, from, as I said, from Kailash area to down below as the river flows, the river Ganges flows, then you will see the religious temples and all other places all around. And any time, any day, if you go to the river Hooghly and Ganges, you will find how many tons. There was a study also that how many tons of flowers are being thrown in the river, and also the material that is used for worshipping garbage. No matter that immersion of the goddess and all that after Durga Puja and any pujas that matter. And very recently, of course, the government has initiated that when you immerse the images, you Visarjan and all that, and after that, they are immediately collected by the government, by the system, by the crane and all that, and thrown away. So this awareness is coming, but it is the universal dumping, garbage dumping channel, or whatever you can call it, rivers becoming a drainage point for industrial and domestic waste and garbage and everything. So the cleanest natural water is maintained, I would say, one example in Sweden, where I've seen, and there are places in Zurich, you can, many of you know that you can drink water from anywhere, in a public water, anywhere. You just take the water and you drink it. But if you did it in our part of the world, within few hours, you will land up, perhaps you will land up in a hospital bed or somewhere, because it's coliform and all other things, and the contaminations and all that. So the clean water and potable water, and maintaining it in pristine form with the minerals and everything, that is something you can only achieve if there is a larger, greater public awareness, and people know about it, and people practice responsibly. And that is bringing us to the topic that can we act responsibly and protect this pristine, the gift of the nature. And again, coming to the upstream and downstream of rivers, in the upstream, if you pollute water in the upstream and carelessly, although you are getting much better, cleaner, better water than those who are living on the upstream, but I mean, irresponsible activities, behaviors, if you spoil it, then the worst sufferers are those living in the downstream. So you can see that that is also happening in many places. But I worked in Indonesia and in countries in Southeast Asia, including China, that I have seen that the restriction is along the river. There is a serious restriction. Even I saw in China, the people were, the farmers were collecting the green, the green spinach and other things they were collecting from the field, and the root the roots had, the root of those, the vegetables, they had soil, and they were carrying it, they were collecting a bucket full of water and dipping that in that bucket of water to clean the mud and all that. When I asked them that, why don't you dip it in the river and clean it up? They said, no, we can't do it. We'll be arrested. Because cleaning that mud from the picked up, the vegetables that you have picked up, is also not allowed to clean up, to clean it and wash it in the stream, in the running water stream. And the water is crystal clear. Absolutely, you can see the bottom of it. So that's the level of awareness, that's the level of awareness and practice and the respect of the government law and this and that. So if it is from there, every person is behaving like that. So imagine from that is, if that is one end, and defecating in the river and discharging all the industrial waste, the other extreme. So anything in between can happen, and that has been happening. So now I would bring you back to the wastelands, that ecosystem in Kolkata. Many of you are from Kolkata, or you visited Kolkata, you know that the Dhapa area, the huge Dhapa area, massive area, the whole, it's called the green belly, or of Kolkata. The thousands and hundreds and thousands of tons of vegetables, fresh vegetables produced there is feeding Kolkata markets and the Calcuttans, and being supplied to other places, many towns, nearby towns and cities. But what is that water is used? The city of Kolkata, with nearly more than 14 million population, with the greater Kolkata, the drainage and the waste and everything, is being carried to Dhapa, and the liquid waste is also carried. It's worth visiting. It's a Ramsar site, in IUCN, one should visit and see that one. And that water, and for many years, this has been going on. From the first tank, settlement tank, deflocculation taking place, oxygen incorporation from the first one to the second one and third one. The flow, the water is flowing, and you could visibly see that the tanks in the beginning, early, like coal tar, black, thick water. And as it is traveling down and crossing, and it is dropping from the, passing through the stones and dropping down and etc. If you walk a kilometer or so, you will see distinctly the water has changed. And eventually that water is so clean and clear, and that's being used for irrigation. But at the same time, there are different kinds of species of fishes and aquatic flora, fauna, which are being used in different quality of water. So that's also feeding the city of Calcutta. Now, use of water, it is bringing back to that we are spoiling it, we are cleaning it up, and at the same time, we are trying to use it to the extent possible. But now, as I said that if right from the beginning, if we are aware, and if we try to keep behave responsibly, then we will probably be successful in not spoiling it beyond that control, and we'll be able to perhaps keep it as close to the quality the nature gave it to us. So that way, I would now like to take you to the next point that we have been asked to, that the groundwater, the wastage, the spoilage and excessive use of groundwater. And I must mention here that the groundwater, as you know, the whole cropping pattern, the crops, the rice crop takes 72 acre inches of water, whereas the pulses and wheat, and there are crops, pulses and oil seeds, they take only 10 to 13 acre inch of water. But Now, if you went to Punjab and Haryana and that side, which are close to Rajasthan, rainfall is very low, water is water is not that abundant as you see in West Bengal, in this part of the world, Odisha and all that, and that, more than 2000 millimeter average annual rainfall, but that side is far less. There, people have started growing a crop which consumes maximum water, the basmati rice, because the money, if you produce basmati, send it to UK, send it to Europe and places and all that, and start minting money. It doesn't matter if it spoils if it creates a huge pressure on the environment, consuming a lot of water, and the groundwater is tapped, and as a result, the water table is gradually going down. Depletion of groundwater is taking place, and on and on and on. And then as you pump out the groundwater, as you know, I'm not going into all that detail. Dr. Ghosh must have highlighted and spoken on that. He's the authority on that one. I mean, see, the whole, the minerals and other many things which are pulled out, and then it forming the crust on the topsoil, and it's affecting agriculture and all that, and carbon nitrogen ratio, and blocking all sort of things. I'm not going into that, but the nature's style of supplying water and then using it and maintaining it sustainably, the human being learned this art for centuries. But if there is a technological development, science and technology, then we cannot abuse it, using the science and technology. I have seen it myself while working in Sudan. I have seen it. I have worked towards Darfur area and towards the Nile, from all the way from Darfur towards, from the bordering area of Burkina Faso and that side, from the Western Africa, people, you will see that thousands and thousands of, nomadic herders walking along with their livestock and everything. 6 months they take walking all the way from Darfur side to the banks of Nile, and another 6 months to return back. Why? Because they have been chasing the rain cloud. As the cloud moves, it drops rain. And as the rain drops in that desertic condition, the green grass grows and the livestock is eating them. And they're moving along the grass, along the rain, and with the livestock, and the livestock grows. It takes 6 months, and from that side, the wind changes and they come back. But precisely growing the livestock, feeding the livestock and chasing rain. And if you eat, I can tell you that, one of the best quality of mutton and the meat and lamb and everything that I ate anywhere in the world was in Sudan and that side. And it's so fantastic. But, it's all nature's gift. But the question is, we can use it, we cannot. At the same time, now, if you come towards, now you can go towards, in Sudan, you will see on both sides of the Nile, 100 square kilometers of green belt suddenly appearing. Brazilians have moved in there, pumping in money, pumping, sucking the water from the Nile and growing massive industrial agriculture on both sides of the Nile and exporting it and this and that. So this is an excess use and, exceeding the limits and not following the rules and natures of the nature. So anyway, there are things which is also happening. There are many examples. And as I said, that wetlands ecosystem and the pristine water in Stockholm, and Stockholm water prize laureates, they are given to those people, those who work. Their pioneering work every year, that has been given. And I was invited a number of times there. I had been there. I met those people working on water, and those who received the recipient of the Stockholm water laureates. And their work is also all mostly on that quality, maintaining the quality, and also related quite a bit to the restricted human use or of the respecting water. Okay, and I have said about this coliform contamination, which Dr. Ghosh has worked extensively, and his work, and I would like to refer to him and his work quite extensively. because he has done pioneering work of the groundwater spoilage, and he has done a lot of work on the recharging the shallow aquifers, and yeah. So now, um, so there are issues. I think I must also mention here, otherwise it will not be good as being an agriculture specialist, that Israel is one of the countries in the world with one of the top highest water use efficiency, and this water that includes the moisture content of the air also, and everything computerized and all that, electronically controlled. So the irrigation in the orchards, my friends visited there and they've seen it, and I've also seen it, that the big orchards, they're irrigated with the sprinkler irrigations and all that. This is also about some 20 years before. And the operator comes in a glass room and sees that it's all quite dry. Then he switches on the switch to irrigate the sprinkler to begin to for the the sprinkler irrigation, all the sprouts coming up from the ground already. Then the second switch, we're supposed to start sprinkling, nothing is working. Then he says things that is there a technical problem or what? Immediately computer gives a reading that the moisture content of the air is high. You can still delay the irrigation by half an hour or 45 minutes. So if that's the efficiency, to that level, that the moisture content of the air is also considered before irrigating or throwing water or sprinkling it. So, that's too far and that's too high technology, this and that. But at least if we could stop spoilage of water, the good pristine water, by creating a massive awareness and all that, will be great. And my work, if you, I have worked extensively in Bangladesh, and my work is now known, which is in the developing world, which is called CLTS, community-led total sanitation. Community-led total sanitation. This is an approach I developed in early 2000 in Bangladesh. And Bangladesh those days used to be one of the countries with one of the highest rate of open defecation, cholera, diarrhea, typhoid, and etc., etc. So people used to defecate in the open, and that, as you know, it used to spread like in many countries, including India and everywhere. But then this work, when people realized, and we were working, when people realized that constructing toilet in your house is not enough unless the entire community is open defecation free. So that means you are still ingesting the other people's feces. And that can only happen if everybody stops open defecation, the practice of open defecation. And if you do not have a toilet, doesn't matter, you can use your friend's toilet or your relative's toilets or whoever, but you are not allowed to defecate in the open. Things started changing from there. And it has become a very, very big program, and internationally that the government of Bangladesh adopted and moved it, and many other countries' governments took it up. The community-led total sanitation, meaning the community took the initiative to stop the open defecation, the practice of open defecation, and immediately the use of the toilets increased manifold. But before that, millions of toilets were constructed, but they ended up in a chicken house and store and other things, and open defecation continued, and there was no impact on diarrhea, reduction of diarrhea, cholera, or whatever. So this is an example of collective community behavior. So now that's and Bangladesh led the way, and now many other countries that followed, and things changed, and Bangladesh became one of the countries in this part of the world, to achieve the zero open defecation free status. But of course, later on with the Rohingya refugees and this and that, things have started changing, but that's a different thing. But the pathway, if you look at the pathway of the public health and stopping that open defecation, that the Bangladesh model is one of the great models. So now bringing back to, I think I have covered some of these points, and coming back to the main topic again, that can we act responsibly and protect the pristine gift of nature, the water? Yes, the answer is we can, and but for which a political will is needed. International, national, and all the countries' political will is needed, and a large scale participation of the people of the community is a must, without which it is rather impossible. So I think, Dr. Ghosh, I don't know if I have more or less covered the points that we discussed. If not, then if you could ask me to throw some more light on certain areas, or I'll wait for the question answer. So I think I stop here, and thank you very much.
Okay. Thank you, Dr. Carr. We really appreciate, in spite of the problems we had with the technical difficulties, I think Dr. Ghosh wanted to ask you just one question, and we wanted
Sure.
to give Dr. Ghosh the opportunity to ask that question, and then we end our program. Okay,
Sure.
Dr. Ghosh, ask your question. Please unmute yourself.
No, I am, should I unmute? Should I mute or?
No, you are fine. I am unmuting. Can you hear me, sir?
Yeah, I can hear you. I can hear you.
Dr. Kaur, if you remember that I have a serious problem I'm facing in Bangladesh of the raw sewage using, and it is so widespread, as you already explained very well. And how this raw sewage, is there any technology or some way to, I know we can make cement and allow sewage, cement's hole, and prevent sewage not to spread. So is there any modern technology available at home or abroad that we just install and later is incinerate and get some amount of gas out, whatever is allowed by each country standard? And in America, and we also allow certain amount of gas to go to the atmosphere. So is there any restriction internationally, or what can be done to start in Bangladesh to stop raw swaging? It is very backward. It is not poor anymore. Everybody can eat and drink. Something still possible to do in Bangladesh may not be possible to do in India. You know, I have some access because of my historical connection, and I did not leave country despite many problems. Is there any recommendation, what kind of immediate action, what kind of devices we use to prevent the spread of raw sewage into the aquifer? It's extremely dangerous, and it is done 50 years ago. Can you do it now?
Yes, I think you know, I can give you some examples from you know, what I saw, very powerful, good examples that I saw in and I met those guys and seen it in their presentations and the materials and etc. in a international the toilet conference in Finland, and also probably, you know, it was in Finland. Yeah, people came from different parts of the world, and they conduct regularly international toilet conference, and this lady, the young lady, came from Kenya, and also one from Uganda, from South African originally, and she brought a bag, a full plastic bag of briquettes. Briquettes, the Bangla we call it gul. The briquettes, the for you know, used for you know, fuel as a used as a fuel for cooking and all sort of stuff. And they were green briquettes filled up in a bag, and she brought the whole bag and gave it to us, all of us, We took it in the hand, and then when she said, these are all shit, all human shit. So she collects the human shit, and actually, and her center is close to one of those IDBs, the internally displaced persons in Kenya, and thousands of people in Uganda or Kenya, and then that shit, human shit, is collected, and that is mixed with some, charcoal dust, and sawdust, and other kinds of things, and the rice husk and stuff, and in a large scale, and they are dried up, and then finally passed through a heating chamber. And those briquettes are coming out dry, and some colored dye is mixed with that. There is no smell, nothing, and they're filled in bags, gunny bags, and sold. And people purchasing it large scale, and it's a good a money making business, small enterprise. I would say that instead of handling human excreta and treating it as a part of the problem and investing money on shit to handle it, because from that point, imagine the distance it travels from the point, from the commode or the toilet where it drops from your body, and it ends up into the finally, it travels several kilometers, and through the pipes and this and that and treatment plants, etc., etc. But
Okay.
the money that you spend on that is huge. It's a taxpayer's money, it's a government money in handling that one. Whereas if you use it as a briquette and other kinds of things, immediately it brings money back to you. So I would say that could be a very good, option for without creating pressure on the government and giving it to people. Yeah.
Dr. Kaur, can I add an extended question if you kindly briefly
Surely.
answer so that we can wrap up our meeting today, and I
Sure,
will
sure.
have an extended meeting or conference with you. Why Indian continent and our culture more civilized and drinking water research began there first? And today we are drinking, when the people were living the Europe, living in the caves, the white Caucasian, and we are in the peak of civilization, drinking water, I reconfirm, drinking water research began in Indian subcontinent, Indo-Bangla subcontinent, where
Right.
why we have been drinking the human shit, and we cannot stop it. How গু খাওয়াটা কি করে বন্ধ করা যায়? Briefly যদি পারেন একটা উত্তর দেন, একটা answer দেন।
না, এই গু খাওয়াটা বন্ধ করা হচ্ছে, দেখুন আমাদের যে প্র্যাকটিসটা, আমাদের the practice, all the in India particularly, people used to walk a distance from home and go to the riverside or go to the bush and this and that, take bath and everything in the pond or river or pond or lake, and then come back home. But this is still practice along the Ganges, Jamuna, this and that. In Hindi they call it Niptan and Nahan. Niptan and Nahan means you go from your home, go outside far away from your home, and ease yourself, clean up your and everything, swim and etc., etc. And then you come back. So that was meaning, the whole idea was keep that human excreta, which is one of the dirtiest, it's considered as one of the dirtiest things, to as far as away from your home, from your living, dwelling area. So that was precisely the principle. And from there, it all started. And as you know that the chua-chui and all that, touching and etc., etc. Now today with this a time of COVID, you can see that even the touch and hand washing and all kind of things and social distancing, etc., etc., it's all bringing back to that particular point that, that this is something, the excrement and human body and human life, there has to be some distance. So this is coming back to your question that, traditionally those things were there and ingrained into our society, but why it is not, whereas in some society, still you see the ablution, after defecation we use water to clean up ourselves. But in Europe and many other places, it is using the napkins, you know, it's not ablution, it's not water cleaning. So, which is again now I hear that it is coming up, because when you wipe it, wiping, it's not that way cleaned that way. Wiping and ablution and water cleaning, those two things, you know, shuchi je kotha apni bolchen, shuchi and shuchutia and all that, এই জিনিসটা ওই সঙ্গে ইনগ্রেন ছিল ওই রিলিজিয়নের সঙ্গে। অসুচি হয়ে গেলে, even you have got to, you know, in childhood we knew that we have to go to toilet and you have to leave all your clothes, and you go to toilet, take shower and change your clothes, everything, or you come back and then wear your clothes, but with the clothes you cannot go inside. So but that's not in every society. You can go to a toilet, remove your trousers, sit on the commode and do your work, and wipe it and come back and put on that thing. That's not, still not acceptable. Or in Indian society, the hand washing and you know, anal cleaning facilities are there in the toilet.
Very good. So we will make, I want to make an appointment with you, talk about it privately. So are we agree, all of us agree to conclude here, or you want to add something? Is that, are you done for today, or what is your recommendation?
Yeah, I think we need to conclude here. Rosalie, if you could please present vote of thanks.
Yeah, okay. First of all, we would like to thank Dr. Kar for sharing his experience with us. We can, you know, schedule a separate conference or webinar that you can discuss about your CLTS project. And I think that would be a very interesting topic for us, because, you know, we
For
are all
Bangladesh in particular, for Bangladesh in particular.
Can I? Yeah.
We are all concerned about this. So on behalf of Iibhb, we would like to thank all the participants. We would like to thank all the participants and our speakers for joining us today. And we hope we appreciate you staying with us. It's a very long webinar series, but we hope that you can again join us in our future webinar. Thank you so
Sure.
much.
Thanks
Thank you
very
so
much. Thanks very much. Yeah.
Thank you.
And I would like to, before you close, I would like to say that if anybody is interested to know more about CLTS and about our institution, the website is cltsfoundation.org, cltsfoundation.org. And you can also see this book, that From Village to Nation, Community Total Sanitation. It's a you know, it's a publication of the Practical Action from UK, and you will find it, and I can give you the link for this book. And there are many publications on that community-led total sanitation.
Okay.
cltsfoundation.org.
We will share your information to our participants. Thank you so much.
Thank you so much.
That
Thanks very much.
concludes our meeting today. Thank you.
Thank you. Thank you. Thank you.